To talk about introduction to phase diagrams. So I will be covering why phase diagrams, all terms and its definitions, system such as system and its types, phase, component, variable and its types, variance, solid as, liquid as, phase rule. Okay. So these are the basic things which you want to know before you start studying the phase diagram, such as one component system, binary component system, ternary system. It is a basic thing before you get to learn the phase diagrams. So first, why we need to learn phase diagrams? We need to learn phase diagrams because it helps us to understand how a mineral is formed from the melt. See how a crystal is formed and which crystal is forming first, like which temperature, which pressure, and which pressure which crystal is forming. So it helps us to understand in a better way. That's why we need to learn phase diagrams. So let's get into the definition. These definitions are the basic things so that you can understand the phase diagrams in a better way. I'll be uploading the phase diagrams like binary component system and ternary system in very soon. So let's get into the basic system and its types. What is system? A system is a part of the universe that is under consideration. Let me explain it in a simple way. So a system is what we consider like what we want to consider, that is called system. Anything under the universe that we have to consider, that is a system. Let's consider in a glass of water, water will be the system and the glass will be the surroundings. Okay, system is anything that we consider under the universe. Okay, system is of four types. One is open system. In open system, it transfers energy and matter to and from the surroundings. I think these are the basic things you might have studied in chemistry. And closed system, in closed system only energy can be transferred and to the surroundings, but no matter can be transferred. Matter is something like um, some transferring of magma here. In igneous petrology, it is a transfer of magma. And in closed system, when no matter is transferred, then it means only the heat is being transferred. Okay. And let's come to adiabatic system. In adiabatic system, no energy is also transferred and no matter is transferred to the surroundings. And when you come to isolated system, in isolated system also the same, no energy, no matter. And in isolated system it has no surrounding at all. But in adiabatic system you have surroundings. Okay, but in isolated system you have no surroundings. See, I have illustrated with the diagram. Here you can see the system, boundary and surroundings. Okay, so next is space. What is space? See, it is a part of the system with a particular composition. Okay, physically distinct, which can be separable from the rest. A phase can be a mineral, a phase can be a liquid, a phase can be gas, amorphous solid such as glass. Okay, uh, consider an example the same. In a glass, if you have water with some ice cubes in it. Now here, although everything is H2O, but you have two phases in it: ice, which is a solid phase, and water, which is a liquid phase. So that is phase, which is physically distinct. Okay, and can be separable from the rest. Next is component. It is a chemical constituent like olivine and pyroxene. See, for example, let us consider uh, Al2SiO5. Let's consider Al2SiO5. It has three polymorphs. One is andalusite, kyanite, and sillimanite. Okay, although they have the same chemical formula, but they form at different temperature and pressure. See, uh, in a phase diagram, number of component, it is defined as the minimum number of chemical species required to completely define the system and all its phases. See, minimum number of chemical species. Although look at this, in Al2SiO5 you have three phases: andesite, kyanite and sillimanite. But All this can be described by a single component, that is a single chemical species, which is Al2SiO5. The same with H2O, ice, water, and water vapor. All this can be described by a single chemical species, which is H2O. So that is called components. So next, okay, next let's come to phase rule. This is very important because in all phase diagrams you will be using this phase rule. So it is very important that you understand it very well. What is phase rule? Phase rule, it is given by Gibbs. It is also called as Gibbs phase rule. So the definition is, it states that in a system of components, phase rule is equal to component minus phase plus intensive variables, which is pressure and temperature. Okay, and also in some systems you will have constant pressure, like 1 atmospheric pressure, and sometimes you may have a constant temperature. So if that is the case, then the phase rule becomes F is equal to C minus phi plus 1. If it is an isobaric system, considered it has a constant pressure, so temperature is the only thing that is changing. So we are excluding the pressure part and including the one intensive variable, that is temperature. Then comes variance. Variance or degree of freedom, which is F. Okay. What is variance? Number of variables to be constrained before the equilibrium condition of a system can be known. So let's consider the same Al2SiO5 system. What is the degree of freedom? So let's consider at point A. See here, degree of freedom according to the Gibbs phase rule, F is equal to C minus P, P or phi plus R. Okay, R is an intensive variable which is pressure and temperature. Now, here at this point, here the pressure is also constant, temperature is also constant. What is the component? One component, which is Al2SiO5, and we have three phases. One is kyanite, sillimanite, and andesite. Okay, so putting that into an equation, 1 minus 3 plus 2 minus 2 plus 2, it becomes 0. So there is, the degree of freedom is 0. When the degree of the freedom is 0, it is called invariant. That is, it cannot move freely in this system. It cannot go anywhere. It is fixed at this point and only this point. When it tries to move away, then the freedom, degree of freedom changes. Let's consider the point B. Here F is equal to component 1, and what is the phase? Two phase. One is kyanite, another one is sillimanite. Okay, and two intensive variable, that is pressure and temperature. So when you put this into the equation, F is equal to 1, that is, it is univariant. Univariant in the sense it can move along this line, it can move along this line and only this line. It cannot go here, it cannot go this side, it can move along this line only, either this way or either this way. And let's consider point C. So here one component and one phase, only kyanite is there, and the intensive variable 2, which is pressure and temperature. When you put this, you get F is equal to 2. So degree of freedom is 2. It can move freely along anywhere in this kyanite phase. Okay, see, as I mentioned, F is equal to 0, that is invariant. F is equal to 1, that is univariant. F is equal to 2, that is divariant. Solidus. What is solidus and liquidus? Let's see. A solid is, you see in a phase diagram, below which everything is solid. Okay, a line below which everything is solid gives the composition of a solid at a point. See, any point below the solidus, here if I take, here if I take, it will give the composition of the solid. Okay. As the same way, liquid is any line above this line, any point above this line, everything will be liquid. Okay, it will give the composition of a liquid any at a point. Okay, it will give the composition of a liquid at a point. This is a forstride phyllite system. Okay, and the next is variable and its types. What is variable? Variable, as I told, there are two types, intensive, another one is extensive. It is used to completely define the state of a system. Intensive variable, variables like temperature and pressure, they are intensive variables with which you can define a system and without which you cannot define a system. Consider in Al2SiO5, without pressure and temperature you cannot define the phases, kyanite phase, andesite phase, sillimanite phase, you cannot define them without the pressure and temperature. They are absolutely necessary for defining. And next is extensive variable like mass, volume, number of moles, without which you can still define a system. See, mass is not really important in Al2SiO5 system. You can, without the mass you can still define Al2SiO5 system. So they are extensive. So that's all. I'll try to upload the further videos of the binary and ternary systems, so stay tuned. Bye.